Hello, hello. How's it going? How's everyone doing? Welcome to another episode of Bitcoin Developers. I am your host, Connor Okus, and it's great to be with you this evening or this afternoon or morning, wherever you are. It's been a little minute since we last live streamed. The last live stream we did was with Bitcoin Xavier on React Native development and using the BDK to create a very basic app. So there's a lot of developers who are building applications, multi-platform applications, and React Native provides a good library to do such things. So if you haven't watched that, feel free to head over to our YouTube channel. I'll do a little screen share here as well. Let's see. What one do I want to share? I want to share this one, yeah. So we're doing okay in terms of numbers here. Like we are at about 450 subscribers. I want to get those numbers up, as I keep reiterating. Like the only kind of real number I care about going up this year is the number of people contributing and working on Bitcoin open source development. So we're doing our best to keep chugging away at creating content. There's a link in there. We've just put a link in the chat as well to the last tutorial we did on React Native. I'm also interested to hear like what kind of content you would like us to start producing as well going into the future. I've got a lot of inbound requests around like BDK and Flutter, or just in Flutter in general, actually, both on the Bitcoin dev kit side and on the Lightning dev kit side as well. So obviously there's a lot of you who have hopes to be able to do like a lot of cross-platform development. So we hope to, if that's something you're interested in, we'll definitely put that on our content list and get that done for you. So some stuff around Flutter. If there's anything else, feel free to leave a message in the chat, hit us up on Twitter, Discord, Slack, wherever you can find us. We're pretty much everywhere. I do want to do a couple of shout outs for events as well. So we've got a few. Flutter seems to be all the rage. Yeah, totally. Yeah, I definitely agree with that. So a couple of shout outs to some up and coming events we've got going on that I'll be attending, and a few of my colleagues will be attending. So we've got TabConf in Atlanta, the Atlanta Bitcoin Conference 2022, Building Builders. So that's from October 12th to October 15th at the Omni Hotel at the CNN Center. That should be an awesome one. They've gone for a slightly different spin on in this conference, where there's going to be a dedicated Builders Day on the 12th of October, and you can find all the information on the website at 2022.tabconf.com. But this is nice because it seems like different projects within the Bitcoin free open source community are going to have like their own dedicated tables, and attendees of the conference can speak to some of the maintainers, some of the contributors to these projects, and depending on their needs, in our case, we are going to have there's going to be an LDK table there. There's going to be a Bitcoin dev kit table there, Fediment, Galoy, Core Lightning. We're planning on helping, users of the Lightning development kit, if they're having issues integrating certain APIs or having trouble debugging certain things, we'll be on call to help you. Or if you want to contribute to the library itself, we'll show you how to get up and running, contributing to LDK. And I think there'll be kind of similar motivations for other teams as well. So look forward to seeing you at TabConf, and there will be some really cool workshop and stuff that you should definitely look into and see what you want to attend there. A host of really good speakers as well. So look forward to seeing some of the talks as well at TabConf. And the other one is the Bitcoin Designathon as well. So that's going on from October 12th to the 23rd. So I'll quickly read this little blurb. So the Bitcoin design community is organizing a designathon. Imagine a traditional hackathon, but this time focused only on design. Our goal is to motivate designers and builders to get together collaboratively, explore ideas and concepts in and around the Bitcoin ecosystem. The Designer-thon will happen in coordination with Bolt.fun, Legends of Lightning tournament, and we are working on coordinating with the TabConf Builder Day. So if you want to find out more about that, you can head over to the Bitcoin Design Slack in the Designer-thon channel and on Twitter as well. And here's a list. This website's amazing, by the way. So shout out to the design community for this one, Christoph in particular. Some cool ideas as well, kind of floating around already. So we've got an academic research site, debunking concerns about Bitcoin and addressing those in new and creative ways, Lightning apps, owl keys, owl coins. I'm imagining there's some stuff around Fediment and stuff there that could be pretty cool. Inheritance. So there's a lot going on. So if you're a designer, creative, developer, you know, team up, definitely make the most of this opportunity to kind of express your creative juices. So yeah, those are two cool events that you should be aware of coming up. And without further ado, I will bring up the guest for today's show. So we have our friend Eric here. How you doing, Eric?
Hey, doing well. How's it going, Connor?
Yeah, good, man. Thanks for joining me today.
My pleasure.
So
for having me.
Yeah, so we're gonna dive into we're gonna kind of do some stuff around LDK today. But before we go into Lightning Dev Kit and kind of rapid gossip sync, as the title suggests, like because you're new here, as in this show, we do like to give the audience a little bit of a background about our guests. So can you tell the audience a little bit about like your background, how you got into Bitcoin and why you decided to work on Bitcoin?
Yeah, certainly. So I got into Bitcoin, I think, back in 2014, mostly because I kept seeing the chain tip bot on Reddit, and it made the impression on me that there was something going on that seemed to be somehow decentralized, but was transferring money, and I couldn't for the life of me figure out how it was possible to be able to have a monetary system without a central server, without like a PayPal-like mechanism. So that's when I thought it would be worthwhile to read up on how Bitcoin worked, which I then did, and my curiosity was sated. And then, purely through a coincidence, about a year later or so, I joined BitGo, where I worked for 3 years. And then in 2018, I had a brief stint as a shitcoiner on Facebook's Libra project. No other way of saying it. And I promptly returned back to the good side and joined Spiral, or Square Crypto back then.
Awesome. And what is the like one or two things that really like motivate you and inspire you to like want to work on Bitcoin?
I love working with applied cryptography, and I think that Bitcoin is probably the most amazing way of achieving that. Just seeing all of your elliptic curve cryptography experiments and being able to verify that things are working as you intend them to, and then being able to just craft and broadcast artisanal transactions. It's very satisfying just being able to see things work, but with some fun mathematical background, as opposed to just well, I think that there are other software engineering opportunities where all you do is essentially hook up a bunch of APIs with one another, and I don't think that's as fun as being able to do something that has a unique edge in terms of engineering challenges. So for me, that's cryptography. For others, it might be hardware or aviation, droning, what have you. But cryptography is the most fun, in my opinion.
Okay, that's an interesting take that I've not heard before. I can definitely see like the twinkle in your eyes as you speak about applied cryptography. So that's really cool. What advice would you give to people who want to get involved in Bitcoin development and start their journey becoming a Bitcoin developer?
Well, so I think my advice would be twofold, and keep in mind the second part of that I literally just came up with. But the first part is, in order to be a Bitcoin developer, you have to be a developer. And I think one of the best kept secrets about software engineering is how easy it is, because people think that it is this really difficult to surmount hill that they have to climb. It really isn't. Just come up with a project. Like, you know, when you're applying for a company, sometimes they'll give you a take-home task, such as build a to-do list app or something like that. You know what? Just do it for yourself. Try it out. See what kind of problem you want to solve, and then use Google and Stack Overflow to figure out what parts you're missing and how to approach them. And that's going to teach you how to think. And then with Bitcoin, it's essentially just an extension of this idea of coming up with a problem and then solving it. Just try serializing some transactions. Try to see, okay, how can you craft the most simple output script? Maybe send some money to it in regtest or in testnet, and then try spending it. That's really, I think, the most approachable way of figuring things out if you're already familiar with how Bitcoin works. If you're still trying to understand what Bitcoin is and how Bitcoin works, my advice would be to read up on some of the fundamental concepts of cryptography. If you know asymmetric cryptography, you know, public and private keys, and maybe a little bit about cryptographic hashing, then that's really all you need. You take that knowledge, you watch this one video that I really love that I can send the link to later, that I think is probably my personal favorite Bitcoin explainer video, and then get cracking and start experimenting. Just, there's really nothing, there's no substitute for getting your toes wet and actually building stuff yourself, because no amount of reading is going to be a substitute for the retention that you're going to have if you actually do what it is that you're reading about.
Fantastic. And just one or two more questions then. What do you say to people that like would criticize Bitcoin for being like a bit boring and slow and lacking imagination and not having much innovation? Would you agree that that's your experience working in the space, or do you totally disagree with that kind of sentiment?
I would actually both agree and disagree. On the one hand, if you're saying that Bitcoin is really boring, then it tells me you probably haven't really worked on it, or you haven't really been following the amount of innovation that has been that has gone into Bitcoin. On the other hand, from a cryptographic perspective, compared to a bunch of other cryptocurrencies that there are out there, Bitcoin certainly is comparatively boring. It doesn't have all the exciting ZK snark stuff going on, or the Peterson commitments and range proofs and bullet proofs that you have in Monero or whatnot. But that's an asset, because the thing about Bitcoin is, with Bitcoin being the only truly decentralized cryptocurrency that we have to date and probably ever will, you want to make sure that the cryptography truly checks out. You want to have full, indisputable verifiability. So you do not want too much complexity on the first layer. That is where the second layer comes in. That's where all the Lightnings and L2s are building on. That is where the privacy is getting added. I think it is up for debate whether it's a good design decision historically that Bitcoin didn't have proper privacy on the base layer, that we have to try to hack it in with Lightning. But I don't think I want to litigate that. And it's, hindsight is always 20/20, but we can't even, we can't know how things would have worked out without transparency on the first blockchain layer. So there's no telling.
Awesome. And yeah, before we talk a little bit about what we're going to do today, what are you working on now? What have you been working on most recently?
Now I'm working on the thing that I've been looking forward to working ever since I joined Spiral. So it's only been like 3 years now. I'm working on Taproot support for Rust Lightning. It's awesome. Really exciting. If you are familiar with Taproot and you're familiar with Lightning, then I think you'll be able to see that it's really a multi-step process for adoption, because Taproot really encompasses a bunch of different optimizations and improvements that you can have within the Lightning protocol. It comes with such things as simply changing the the transaction outputs to be Taproot trees, to be tap trees, as opposed to just pay to script hashes. So if everybody were to adopt that, it would add the privacy benefit of channel opens being indistinguishable from other transactions on the Bitcoin network. But Taproot also enables things such as PTLCs or point time lock contracts, as opposed to hash time lock contracts, which is something that is provided because Taproot supports Schnorr signatures, and there you have all of those linear homomorphisms that you can very easily exploit, and that allows you to have the additional privacy benefit of having non-correlatable multi-step payments between Lightning nodes. So right now, if you had multiple in-flight HTLC transactions be broadcast on-chain, then due to them using the same hash and therefore the same pre-image, you would be able to cross-correlate them quite easily, even though, of course, it's a fairly low probability event. With PTLCs, that would no longer be a possibility. So it's really exciting. It is, however, a lot of work and takes a lot of testing. But I hope that we're going to be able to get something out and into the hands of developers soon.
Fantastic. And yeah, again, just before we go into what we're going to work on today, let me share my screen here. Where is the best place for people to find you? Oh, I'm still sharing. Okay, cool. I've got your Twitter up here, and you've got your Twitter in your little next to your name here as well. Is that a good place for people to find you? And
my Twitter at arcolive is a good place to find. I've realized that self-promotion is really important. You know, I came across this question the other day. What's the difference between Bitcoin, the payment network, and Bitcoin, the currency? And I think especially with the recent price volatility, the answer is fairly obvious, that the Bitcoin, the currency, is actually the friends we made along the way, also known as our Twitter followers.
Yeah, you never know when that audience that you build up will come in handy one day. You never know, right? All right, cool. So let's talk rapid gossip sync. I've got your blog post up here, but let's try and give the people like a very basic understanding of what rapid gossip sync is, why it's important, what component within the Lightning protocol stack it affects the most, and kind of how it's used.
Yeah, certainly. So if you are building on Lightning, and especially if, like me, you have also been working with other developers who have been building mobile apps that are supposed to use Lightning, you will notice that one of the issues with the Lightning Network is constructing and routing payments. As we were talking, as I mentioned previously, Lightning is all about, well, partially about privacy. It's, of course, also about speed and some other improvements. But particularly with privacy, Lightning builds on the Onion protocol that Tor uses. And in Lightning, it's called the Sphinx protocol. And what it does is it allows a payer to construct a route for their payment to the eventual payment recipient. However, the intermediate nodes don't actually know who the original sender or who the final recipient of a payment actually is. They only see their predecessor and their succeeding node. So that, in principle, is really nice. However, in order to be able to construct such a Sphinx package, you as the payer need to have visibility into the channel graph. So you need to know which nodes have channels open with which other nodes and what the capacity of those channels is, such that you can verify that the payment that you're routing is actually going to have valid routes. Maybe it's going to have to be split up into multiple routes with a multi-path payment. But on a mobile phone, and really honestly, not even just on a mobile phone, even if you're running a computer, in order to obtain that channel graph, you have to download it. And typically the way to do that, as per the Lightning protocol as it's laid out in the bolts, the way to do that is through the gossip layer, where you connect to a node and over TCP. You don't need to open a channel, just connect to a node over the TCP protocol. You ask for the channel graph data, and then that node will just give it to you. And as you are receiving the channel graph data, hopefully you're connected to a Bitcoin full node, such that as for each channel you're getting the SCID, so you can verify that there is indeed a transaction and a UTXO that has not been spent, that channel is indeed open, and that everything checks out, that the signatures are correct. And well, you're basically doing your due diligence, and it can take upwards of a couple minutes for you to finish downloading that network data. If you have your Lightning client running a computer and you never turn off your computer, or it's maybe even a server, then that is perfectly fine. If, however, you're trying to build a mobile app that maybe is supposed to mirror the user experience that you'd have with the likes of Venmo or a Cash App, then what you have is you are operating with the constraints of an operating system that's going to try to purge your memory and your RAM as frequently as it can if the user isn't using it a lot. And considering that you don't really, well, that making payments from your mobile phone is not really an activity that you engage in a lot, odds are maybe you haven't opened the app in a couple hours, hell, maybe even a couple of days or weeks. So when you open it, it means that in order for you to be able to send a payment that is truly private, you first have to wait several minutes in order to be able to sync that channel graph. Like, imagine having to wait several minutes as you open Venmo just to be able to make a payment. Even if the apps are all about the dark patterns and they require that if you don't have the latest version, you download that first. I mean, you have fairly low connectivity or you're somewhere remote, it is not going to take that long for you to do so. So that just sucks and is horrible UX, which is why so people have been able to address that previously. And the way that they addressed it is, instead of constructing the packet and constructing the route on the mobile phone, they ask a server to construct the route for them, which, however, comes at the expense of privacy, because now the server knows whom you're paying, and they know everything about your payment. They know whom you're paying and they know how much. So that means that even though you're using Lightning, your payment history suddenly is, I think we say that in the blog post, that it's suddenly just one data leak away from becoming public knowledge. And anytime you have any data on a server, even if you are not actively trying to store it, odds are you have some logging enabled, or AWS has some logging enabled for you. So if it gets hacked, or more realistically, once it gets hacked, because it truly is a matter of time, yeah, your data is compromised. So what we try to do with Rapid Gossip Sync is allow you to download that payment graph, that channel graph super quickly, within a matter of seconds, such that mobile apps don't have to rely on a server to be able to obtain that information. And credit where credit is due, by the way. The original inspiration for this was LN Sync from Blockstream, built by Christian Decker. And Rapid Gossip Sync is an improvement that is addressing a different use case, and that is also compressing the data by a lot and omitting a bunch of intermediate updates that are no longer necessary. Like, we really try to squeeze as much information as we can out of as little data as possible. So if you want to read up on the intrinsics and the internals of the protocol, I believe there's also that README link on GitHub. Yeah, that one. So I can encourage people to read up on that. And if you want to read even more, then you can actually read the source code. It's I dare say so myself, rather nifty. It's quite cool how well we've been able to compress it. Of course, it does come with a slight expense of you either having to run your own rapid gossip sync server that is going to be able to take that gossip data and compress it, or rely on a semi-trusted already existing server that we have deployed at this URL that you see in the first code snippet box there, starting with the curl-o. But I think it's worth the trade-offs. And if you are building a mobile app and you want to give it a try, I imagine you'll find yourself agreeing with me that it really is worth it. And it is a massive improvement. And it's until you try it yourself, it's truly unbelievable how fast this thing works.
And we will be trying it very shortly. So are there any, there's a lot to take in there, obviously, but is there any privacy implications or negative privacy implications using RGS? And do you expect just like each project to run their own RGS server? Can they just use ones hosted by anyone in the community? Does it matter much? Is it beneficial to have access to multiple RGS servers?
So privacy is not directly a concern, because when you're querying the data, the server does not actually get anything about you, any information about where you're trying to route payments. Privacy might become a concern indirectly. So what the server could do, if we were to assume a malicious RGS server, it first of all could log your IP address, so it could find out who all of the various Lightning nodes are. And the server could also try to return to you a fake or a malicious graph, which might, for example, try to route all payments through a node that the server controls. So that would be an indirect privacy compromise. The server could also alternatively feed a malicious graph to every single client. And in so doing, if that server has sufficient usage, possibly trigger a DDoS of a particular Lightning node simply by having so many other clients try to route their payments through this particular node in the network. So the server could do some malice, but it's definitely not as easy as if you had a server that's simply returning a payment path to you directly. So there is some indirection involved. I do think that personally, I would recommend that people run their own rapid gossip sync server, because it's not really that much effort to run. We do have the server code available and in the same GitHub org. Just go to Lightning Dev Git and then rapid gossip sync server there. We also run a server of our own if people just want to experiment with it. But the thing is, if you're building a mobile wallet, I think odds are that there probably are some components that you're building that require a server where your apps are going to be able to connect to the server anyway. So if you're already doing some server work, you might as well run your own rapid gossip sync server. I think it's just better.
Okay, that's cool. So it can just plug into already existing infrastructure anyway.
Yeah, exactly.
Very cool. Okay, cool. So let's start talking about the demo we're going to do today. What are we going to do? What do we hope to achieve in today's demo?
So the demo shouldn't take too long. Really, it's actually rather trivial, because all we're going to do is we're going to download a snapshot from an already running rapid gossip sync server, the one that is hosted by us, that whose URL you see right here, rapidsync.lightningdevkit.org. So we're going to download one snapshot, and then we're going to apply that snapshot to an empty network graph that is exposed by the Rust Lightning bindings. We're going to do so in Kotlin. So here in that code snippet, you see us doing that. You see an example of us doing that in Rust. We're going to do that. We're going to do pretty much the same thing, but in Kotlin. There are really just 2 or maybe 3 steps involved, depending on how you choose to implement it. The first step is we're going to get the snapshot, and we're going to get the full snapshot because we want to demonstrate how long, or rather how little it takes to download the entire network graph. Then we can either persist that snapshot data to a file, or maybe we'll just put it into a variable in RAM. And then lastly, we are going to take this network graph object. We're going to wrap it in a rapid gossip sync struct that is going to have a reference to that network graph such that it can update it and modify it. And then we're going to either feed the file path or the raw snapshot data to the rapid gossip sync struct such that our network graph can be updated. And just such that people trust us and see that we're not trying to fool you, maybe we can output the size of the network graph beforehand and maybe also measure the amount of time that elapses. And then after we apply the rapid gossip sync snapshot, we can output the size of the network graph post application, and maybe even list the channels and the nodes and just count how many we have created. So if everything goes right, it should work.
Okay.
So let's try then, shall we?
Let's give it a go. So let me try and get set up for pair programming mode here. Let me move a few screens around. How's everyone doing in the chat? Please let us know if you're still with us and we're making sense so far. We're gonna move into the practical side of the stream now. Let's I don't know what that
an emoji in there.
Is. Oh, that's a thumbs up. All right, cool. Let me share my screen here again. Thumbs up from Xavier. Yeah, I'll do entire screen. Or maybe, so I'm just in IntelliJ IDE. I've just got a basic starter project set up. I'll just increase the font size slightly just for people on the stream. And whoops. Okay, and I'll just run this just to make sure like it can run fine. So yeah, we got our standard hello world there. So yeah, like Eric said, we're going to be using Kotlin in the JVM environment for this, but the same applies if you're building an Android application and you want to use Kotlin, or on the Swift side, LDK does support Swift as well, so you can also use Swift if you're building iOS applications, as this is targeted to mobile clients. Cool. So what do we want to do first? I guess we want to
link the bindings. Let's just double check and make sure that we can link the bindings, that we can.
Okay. Yeah, so where does a developer get the bindings from, or I feel like bindings is a bit of a confusing word. They just want to import the Kotlin library for LDK, right?
Right.
Yeah.
Yeah. So I actually have to admit I have not worked with Kotlin before.
Luckily, I have.
Yeah. So I believe there should be something on Maven that's already pre-existing, right?
Yeah. So I think if you just type in Lightning Dev Kit, yeah, we have our org set up here, and if we click into LDK Java version, so yeah, so you can add it to a project in multiple ways. If you're using Maven, you can add your dependency this way. We're using Gradle as our build tool, so we can pretty much just copy this command here and add it to our build.gradle file. The latest version is 0.0.1.10.3. I think we have another release coming up soon as well, don't we, Eric?
Yeah, I believe 1.11 should be coming out shortly. Hopefully this weekend, but who knows? I hope we don't have any complications.
Yeah. he says crossing his fingers under the table.
Yeah.
So yeah, so we'll add a dependency here. We'll add LDK because we're operating in the JVM environment. We'll use LDK Java. We'll save it and then we'll just rebuild the project quickly. Cool. Looks like there's no issues there. And then do you know what we want to do if we want to like import LDK to start using it?
I have no idea. However, I do know what we want to do if we want to verify that our import is actually working.
Okay.
Do enlighten us. How do we import LDK?
So I guess you can do it two ways, right? You can just import, and I think use org dot, and then look, IntelliJ is doing the nice code completion stuff for us, and we've got access to all of our structs and enums and utils and all of that kind of stuff. So maybe for now we'll just import all of our structs like this, and then to test that's worked, I guess we can try to like instantiate something from LDK just to make sure it's like working. Maybe like
we could try to instantiate a logger perhaps, or a network graph.
Okay, yeah, I think we're gonna need a logger later, aren't we? So yeah, we can try a logger, and it's got all the nice code completion for us. So if we do that, and then we want to basically create a new instance of a logger.
I think okay, gotcha.
And we'll maybe, to make this easier, we'll just create this in a different object. So we'll call it LDK logger, and create an object down here that is logger on LDK logger. And I guess we want to implement the logger interface. Oops.
Wait, that's the wrong one. I think the first suggestion was the right one. Yeah.
Okay, yeah, there we go. And then
just press Alt Enter. I believe that should on the
Okay, so this is saying object LDK logger is not abstract and does not implement abstract member.
Just press, implement methods. That'll
so there's something we need to implement here. So every time we instantiate a logger, we have to have a log method. So IntelliJ is nice enough to kind of just do that for us. And for now, I guess we can just print line. We just print the args we get from record, I guess, for now, and assume it's not null. Okay, cool. So that was just to demonstrate we've successfully imported LDK anyway. We'll remove this print line and we'll just create a few spaces because we might use that logger later. So okay, cool. We've successfully set up the bindings or the Kotlin library for this project. What do we do now? What do you want to do now?
Well, let's just run it and verify that it works. I think
sure.
Frequent running of your code is critical.
Yeah, sure. Cool.
Right.
So we didn't print anything this time, but build was successful and it runs successfully, so that's good. Cool. So we've successfully imported and built and run a project. Where do we want to do now?
All right. So I think the next thing we want to do actually has precious little to do with LDK itself. Let's download our first snapshot, shall we? So maybe let's let's assign the URL of the snapshot to a variable. We could copy paste it from the GitHub or the docs.rs link that you had there in your browser previously.
Oh yeah, I've deleted it, but it was we can just head over to.
Or I could also send it to you out of bounds.
Yes, please. That might be easier. Yeah.
Yeah, I unfortunately
you
cannot directly comment in the Twitch comment section. So I sent you a Discord message, and that you should be able to take.
Okay, no, I found it. It's cool. I've got it here. So yeah, if you want to get the URL for the RGS server that the LDK community is hosting, you can find it here.
Right.
So I guess we're also gonna want to make like a request to this endpoint as well. So
right. That'll be a get.
Yeah. So what I'll do is I guess I'll just make a function that just does just that, and I'll call it like get rapid gossip sync snapshot or something.
Yeah, that's a good name.
And so when we make a call to this server as well, what does it return? Is it like a JSON object? Is it just raw bytes, like a string? Like what do we actually get back?
It's just raw binary or an octet stream. If your client supports it, it'll be gzipped, which reduces the size by about 50%. It's so it should be about 2 megabytes in transit, but most clients that support gzip decompress it or inflate it under the hood. So once you look at the returned data to you, it should look like probably 4.7 or so megabytes.
Okay, awesome. All right, so I'll do what you mentioned earlier and just create a variable for our URL, which is here. Yeah.
So if I may note something here, last sync. So obviously remove the /n. Last sync timestamp is a parameter, and it's basically so you want to pass in what timestamp you have received from the last gossip snapshot that you have processed. If you have never processed a snapshot before, you just pass in 0. And when you process a snapshot, it returns to you which timestamp you should be using next. So it's all encoded in the binary therein. So that also guarantees that it's going to be a valid timestamp, because not all intermediate timestamps are used. We only produce snapshots every 24 hours because there isn't typically much exciting stuff going on in the interim. And that allows us to also have a finite amount of snapshots as opposed to having to calculate a dynamic delta on the fly, which would take significantly more time.
Okay, makes sense. Okay, so I've got my URL, and I guess I'm gonna need a way to make basic HTTP requests to this server.
Right. So I guess that's a question of whether Kotlin is as verbose as Java. Do you need a buffered input stream reader that wraps whatever else? Or can you do
maybe I've been using something called Couture, which seems to be like an easy way to do this. So we can try just adding Couture quickly, and seems like all you need to do is add it as a dependency, add the version, create a basic client, and then just make a GET request, which seems easy enough. And then you can just return the response body, which seems pretty straightforward. So let's give that a go.
It looks like it's blocking.
So well, not now because I've put it in a
suspend function.
Yeah, in a suspense function, so it should be okay. But let's see.
Well, I mean,
and it doesn't matter too much for this Excel anyway.
Yeah.
Okay, let's add this to our. Let's comment this out first because that's going to error because we've not returned anything yet. But we will add this as a dependency. And I guess we need the latest version here, 2.1. 2.1.1. Let's build our project again.
I guess while it's building, I also want to give a shout out to Steven for sitting in the background and helping us with all of this. So thank you so much. Appreciate it.
Yeah, nice one, man. All right, cool. So we have Couture's built in now. So if I just go back to the docs, it looks like it's as simple as instantiating a basic HTTP client like this. So I'll just copy that here. I'll put it under here. So we have our client. It's going to moan at us because we've not imported the right stuff. Just hover over it and import.
By the way, if you press Alt-Enter on a red thing, it'll make it a little faster than with waiting for the hover pop-up to show up.
Okay, cool. So, oh wait, hold on. Alt-Enter. Okay, we'll do it on the next one. So, okay, so we have a HTTP client now. What else does it say? Okay, and then yeah, just to make a basic GET request, we do something like this, and we will swap out the URL they've got here for our variable, and Control N. That doesn't seem to work for me. Oh, there we go. Yeah, there we go. I want cool. And I guess we just want to return a response from this function as well. So I think you should be able to just do like response dot body, I guess.
And I think it probably needs a type for the body, right? Because it needs to realize how to interpret it. And in our case, we just need an octet stream. So can it implicitly convert things to a byte array? How do we get a? Are there docs for that?
Let's see here.
Scalar array, byte array content, string value response, byte array. Yeah. It's as simple as this. Here, I'll post it in the private chat backstage. I got it from this URL, by the way. So it should be all we need to do, I think, is just specify the type of your response variable. Say, val byte array something.
Got you. So let's see, client. Okay, so if we do something like this. And then we want response.body, and
return the byte array body, and it's all good. Perfect.
So
now
we can just inline that as well. Actually, yeah, we can just do that, which is nice.
All right, because I guess Kotlin can realize that it's an implicit. Well, actually, no, I don't want to return that inline like that because. Never mind. Let's do that. Let's keep it with the inline thing that it had been, but I want to add another check. So let's in the main function. Let's call the gossip sync snapshot getter. So let's say snapshot equals whatever.
So val snapshot equals and then get rapid gossip sync. I guess this will moan at me because it's not running in a coroutine or something, isn't it?
Right.
Yeah.
Well, I don't believe that your get rapid gossip sync function even needs to be a suspend. I think they all seem to be fine doing everything synchronously. So maybe if you remove the suspend in line 23, will it still work?
Let's see here.
Yeah, seems to. Oh, wait.
Okay, no, we're getting some suspend function get should be called only from a coroutine. It's okay. I think for now we can just block the whole thing and just block the whole main thread and just run it inside a unblock thing. For now, it's fine anyway.
Does Kotlin support a suspended or a coroutine main function?
I'm not sure. I feel like it does, but I can't confirm, to be honest. I'm not sure. Sounds like it does, but yeah.
Well, so now let's use a little trick of mine. So I don't know if it works like that in Kotlin or it does like that in Java or just in Java. So I would type SOUT tab. So this is a IntelliJ shortcut. So underneath in the next line, SOUT and tab. Okay, so in Java, it's system out print line. So there it's a little more helpful. I guess here it's not necessary. But anyhow, we can do whatever you want. So let's just print like test or something and set a breakpoint on line 14 because I wanna inspect the snapshot value that we're getting before we proceed further.
Okay, so
yeah, this is fine. Yeah, just we can even have an empty string there, whatever.
Do we want to print and we want to print the snapshot?
Oh God, no! It will mess up your console. Snapshot.
Okay.
I think a breakpoint in line 14 would be better. Right, and let's debug this one.
Okay.
All right.
What have I got? Let's see.
Wait, it's not working. I can't debug.
Variable snapshot is never used. Blah blah blah. Let's see.
Some Kotlin can be. Please update the Kotlin. I guess you need to update the plugin in order to debug. Okay, never mind. Let's not debug then. Let's print instead not the snapshot, but the snapshot length.
Oh, okay. So I can use a inline variable here, and get in the length. I guess size or count, if I remember.
Size. So it was suggesting size.
Let's see, snapshot dot size. Okay, let's do that for now. Let's see if that works.
You're debugging. I think you want to just press play.
Oh. Let's see here. No, that's weird.
Did I break it?
No, I don't know. Let's see. Hold on. Let's run it again. Gradle cache modules. I have no idea what this means. Module was compiled with incompatible version of Kotlin, the binary version of its. Ugh, that looks like a really ugly message. Expected version 1.5. I'll try one. I'll try one thing that usually helps if I just invalidate the caches quickly and see if that works.
All right.
The joys of live coding.
Yeah, man, I'm sorry. I hope it wasn't the debugging that broke it.
I don't think so. Let's just be a bit patient here and see what happens.
I have two hypotheses. It could have either been the debugging or it could have been the import of the Ktor client. So just to make sure, we could also.
Oh, maybe you're right, actually.
Yeah, those are two changes. That's why I like to iterate and press and debug very frequently, just to make sure that I know which change was.
Yeah, I actually remember having this problem before. I think I might need an older version of Ktor, actually.
So it was Ktor. All right, that's a relief. At least it's not LDK breaking it.
No. I'm just trying to remember what version. Let's just try and use an older version.
All right.
Where can we find the versions of Ktor first? If I go to maybe releases. 2.1.0. Let's try 2.1.0 because I do remember using that the other day and it was fine. Let's try that.
All right.
If not, we'll use an even earlier version. Okay, that's fine. Scanning. Okay, let's try run now. It's not happy, is it? Module was compiled with incompatible version of Kotlin. The binary version of its metadata was 621.
Well, maybe that's because you only changed the patch. What if we went like 200 or 202?
Yeah, let's try 200. Yeah, I should have used, probably shouldn't have used a newer version, but let's try 200.
Could you cheat and look up in the previous project where you build 6? Well, this is just the Maven thing. In the previous project where you've been testing things, which version you used there?
No, because I only put the code for like the main in a gist. I didn't actually save like the dependency file that I used. But let's try this one. If not, so build successful.
Okay, this looks promising.
Okay, cool. It's working now. We're
right.
good.
However,
but
it's not printing the snapshot thing.
It's not printing the snapshot. Okay, let's see why not. Returns the number of elements in the array. Okay, let's run it again.
All right, so let's try to add a print line before the run blocking. Just
for a sanity check.
Yeah, sanity check A, because we're gonna have several. I also want to add a sanity check B underneath the run blocking. It's not printing anything. All right, what if you comment out the run blocking? Another sanity check. Perfect.
Let's see.
Okay, I think. Okay, so I know what's going on. I don't think it's when you press play, it's building Maven. It's not pressing play on this thing. So press the play on line 10.
Yes. Oh no.
That is weird.
Run.
Main
I wonder if, let's see if we can run it in debug mode again, connected to
the hell is going on? Oh, now it's stopping there. Okay, so let's press play and continue. So I mean, no, not that play. Sorry.
And debug mode. There's
a separate play too. Yeah. That one. No. Two icons below that one. That one. Yes. Resume program. Yeah, that one. And let's look at the. Can you switch to the console tab there? No. The console, that one. What the hell?
That is weird. What on earth? All of a sudden we can't print.
Okay, I know what's going on. You have this import, the print line import. It's not a standard import. It's a weird one that for some reason IntelliJ suggested. The Java SQL print line, we don't need that one. So let's remove that. And let's try running it again.
That's why I like to manually import, because I end up importing all kinds of stuff. But good debugging there. Thank you.
All right. So no, let's uncomment the run blocking thing.
All right. Let's rock and roll again.
All right. And press play again.
And I'll just delete this and we'll run it again.
Yeah. By the way, are you on a Mac? Yeah, you are on a Mac.
I am. Yeah.
Command delete or command backspace, it removes the line that your caret is in. Okay. So you don't have to select everything first.
Okay.
Sorry, I'm just working with IntelliJ so much. I love IntelliJ.
Yeah, I'm new to IntelliJ, to be honest. I'm more of a VS Code man, to be honest.
I hear you. I'd be nothing without IntelliJ. All right.
Okay, cool.
This looks correct. It is 4 megabytes and 893 kilobytes, 134 bytes.
So this represents like a complete network graph right now.
Yeah. So if you were to download a network graph in non-RGS serialized format, it would take up like 70 megabytes. Here, over the wire, it was like probably around 2. And post gzip inflation, we have almost 5 megabytes. It's massive savings, in my opinion. I think it's just unbelievable.
And do we want to quickly measure how long it took to do that very quickly, or?
I mean, we can. However, I think everybody watching this can see that we press play and it just is immediately there, right?
Yeah, I'm with you. Cool. That sounds good.
Are you able to return a variable obtained within a run blocking block to the outside world? Like, would you be able to assign snapshot to something that is running outside of run blocking?
Yeah, I guess you could, but for this, I guess we don't really need to. We can probably just do everything. We can just do everything in here for now, anyway. Yeah.
So here's what we want to do next. Then we want to instantiate a network graph object, and we want to instantiate a rapid gossip sync object. But in order to be able to instantiate, and so let's just do, you know, val network graph equals network graph impl, I believe it's called in Kotlin.
Network graph
or new impl. Oh, off. Okay.
Yeah. Okay. And this takes a Genesis hash and a logger.
All right, so here's what it actually needs. It needs a reversed Genesis hash, or at least a Genesis hash and little endian notation. So let me cheat in this instance and send you the mainnet reversed little endian Genesis hash in hex. And then do you have some hex to byte array library?
Yeah, we can do that as well. So this is like reversed Genesis
hash hex,
and you've put that in the chat. Cool. Why is it reversed and not just like?
Due to the big endian, little endian notation. So everybody who is normal uses big endian notation because that is what we're used to. When we write decimal numbers and we see, say, 2,367, you know, we have the most significant digits on the left-hand side, which is 2, which is for 2,000. It comes first, and then the least significant digits are in the end. And within the Lightning Network, this is how most things are noted also. So a big endian in any base, you know, we use base 10, but here we use base 2. We still want the most significant bits on the left. But Bitcoin, for some reason, decided to use little endian notation, and I think, yeah, the Lilliputians definitely would not appreciate that.
Okay, cool. And we need a what is this?
To byte array. So I believe if we can parse hex, is there a thing where you can just take hex and then call to byte array, or do you need a special hex parser library for that?
Yeah, I think we need a special library, and there is a quick one we can import by Google called Guava, and that's got all our that's got all the utils there. So let's add this quickly, and we'll use the utils they provide there.
By the way, a note to our viewers: when it comes to third-party dependencies in actual Rust Lightning code, we are nowhere near as nonchalant about that.
Yeah, that's a good point. Actually, I'm just adding like dependencies all over the place, and for mission critical software that dealing with money, you probably shouldn't do that. I'll write a quick function then to do this. To array, and we want it to return a byte array, and then we can use the base 16 encoding. I think we want it to be. Do something like that.
Oh, does it require the thing to be in uppercase? That wouldn't work. Interesting.
Okay, cool. So we have our little 2-byte array method thing. And then, okay, so we have our network graph, and it takes, what does our network graph take? It takes
two
a,
things.
yeah,
The Genesis hash and
mm-hmm.
the logger. So we could, I guess, move the logger up a bit. By the way, what you can do, if you can move your cursor to line 19 and then Alt-Shift up arrow.
Alt-Shift up arrow. We can just move it here, I guess.
Yeah.
Yeah. Okay, so sorry. So it takes a reverse Genesis hash, so but as a byte array. So
right.
We can just call our 2-byte array function on it and also pass in our logger. Cool. So it looks like we've got an instantiated network graph.
All right, excellent. So let's perhaps print its size. So let's do another print line, and then network graph size.
And then
the $sign curly braces thing, because we are going to want to call a method on it. Graph period. Let's see. Wait, I don't know. Could you show the suggestions again before, without the size? Just remove size and press Control space. Right. Only okay. Oh, actually, I have an idea. Let's do. You know what? Go to read only, because we want to have a readable network graph. So press read only there. Yep. And then a period.
Yeah.
Let's do list channels. Well, you skipped past that. List channels. There we go.
Okay.
And now period again, because this is an array. And size.
Okay, cool.
So this is the channel count. We also separately have the node count. I guess you could print them both.
Wait, so this is this will, but this, okay. So where we haven't used the rapid sync snapshot at all to like.
Precisely. So this is to demonstrate that we're starting out with an empty network graph. Also to verify the network graph is working properly and as expected, to make sure that all the methods, that it's instantiated properly, that the methods work, all that. This is a sanity check. All right, excellent. So maybe change size in that statement to channel count, because it relates channel count. Wait, no, in the string that you're outputting.
Okay, here.
Right.
Network graph, channel count.
Yeah, and press Command D.
Command D.
And let's do the lower one for node count.
Node count.
And then there, instead of list channels, we can call list nodes. List nodes. Does it also have a size? All right, and let's rerun it. I hope it works. Okay, excellent. So now let's instantiate our rapid gossip sync struct and apply the snapshot.
Sounds good. So is that we have something similar? Is that just like rapid? Okay.
Rapid gossip sync off, and then we instantiate with a network graph. Right. Cool. So there we go. And then all we need to do is we call rapid gossip sync. So just write rapid sync there, and then period.
Yep.
And okay, update network graph. And we want to pass in the byte array, which is the snapshot.
Which is here. Okay, cool.
Right.
Snapshot. Yeah.
And let's assign that to an update result. So let's results equal, val result.
Like that updated result or something.
Right. And now I don't really know how to interpret result. I have because I don't know what it's going to look like in Kotlin. So let's set a print line after that is just empty, such that we can put a breakpoint in there. Oh wait, no. Press undo. Command Z.
Yeah.
And enter print line again. And now
Yep.
stop. Oh, okay. I think now you got the right one, because previously I think you selected one that was different and it may have imported some stuff. So let's just
Shit.
verify
Okay. Yeah.
that it didn't import something weird.
Yeah. I think we're
No,
good this
it did not.
time.
Okay, good.
Yeah. Yeah.
All right. So I don't know if it needs to take any arguments. If it works with just an empty argument list, then even better. So let's put a breakpoint on line 25 and hit debug.
Breakpoint and hit debug. And now we want our debugger. Do we want the console first?
Man, that's taking its sweet time, isn't it? Is it stuck? What's going on there?
Wait, no. Well, we're not printing anything, are we? So it's just.
Well, oh, is it right there? So can you go to debugger then, to the debugger tab?
Yeah.
And whoa, why don't you have any variables there?
That's a good question. View breakpoints.
No, view breakpoints is not it. So I want to look at the network graph. Can you evaluate expression? So or add a watch here. So do evaluate expression.
Do a what expression?
Under variables, you see this little thing, this little text field under variables where it says evaluate expression on the right, in the bottom window on the right hand side. There, right there.
Oh yeah. Oh
so press it. And then let's enter updated result.
So we just want this one.
Right. By the way, technically it's the update result and not the updated result, but it's not working. Okay, never mind. No debugging for us. Let's do it the old-fashioned way with print statements, like the cavemen that we are.
Okay. But what does so hold on a minute. Let me just get my head around a few things. So update network graph is actually returning an byte array with update data. Okay, cool. So what does that actually mean? What does that have on it? It has.
So it's a result type, which means that it either has an is okay, so it's either okay, or it's an error. So if it is an error, we probably want to maybe, you know what? Maybe do you have like an assert or something where we can say system exit status? So I know what we want to do. If update result, let's start an if clause where we check if update result is not okay. So if not, if bang update result okay.
Update result is okay. Yeah.
And then we just want to. Oh yeah.
No, it's just a parameter. Okay.
Then we just want to return, and maybe print update result is not okay, aborting.
Okay. Like the caveman. Yeah, that's funny. Okay, cool. Update result not okay. Aborting. Cool.
Yeah, and let's add a return statement there underneath, such that it actually does abort. Well, right underneath that print line there.
Or just a straight up return.
Yeah, and then outside the if clause. Wait, why can't you return? Why is it complaining?
Change to return at running block. Well, I guess we don't really need to return. We can just see if it errors.
Okay, we can just say it's not okay. All right, whatever. So then, let's see. Can we? So there is it's an enum, and we should be able to take its value as an okay result, because if it's okay, we should. The result is going to be the timestamp that we're going to need for the next network graph. However, before we do that, before we figure out how to do that, here's what I would do. So maybe let's take lines 19 and 20 and copy them to underneath that if clause.
So here.
Right. Yeah, and let's just press play again. No need for the debugger. Yeah, man. This it's getting stuck. It's not calling it properly. I'm not sure why. We maybe need to call to pass the snapshot with an exclamation mark or something like that.
Let's see here. So we've called rapid sync with. Where are we? Where are we instantiate? Okay, rapid sync with our network graph.
I have an idea what it might be. Maybe the read-only causes some locking problem on the backend side. So let's comment out lines 19 and 20.
Interesting. These two, yeah.
Yeah. And press play again.
It shouldn't though, should it really?
Yep.
Oh, maybe.
It does. A locking. It's a lock thing. So I guess the debugger would have worked. If you like, we could put a breakpoint in line 29 and inspect what the hell we're dealing with that update result there.
Okay. On line 29 and debug from there, yeah.
Yeah. So this should give us. There we go. This is what I wanted to see. Unfortunately, it's a little small on here, so I really have to zoom in. But if you could, you see the update result thing there? So maybe if you could expand it with that button on the left.
Yeah.
Well, that's useless. All right. Well, it was worth a try, but with the bindings, I guess we do have this layer of indirection that makes debugging a little more difficult than I guess it would have been had it been a native Kotlin object. Even so.
Okay.
So we have now demonstrated that after running this and calling that read-only thing on the network graph, we all of a sudden have, could you go to the console? Or maybe we run it again without the debugger.
Yeah. Oh, without this.
Yeah. So we now have 87,000 channels and 88,000 channels, surely if we round up, and 16,000 nodes. And we did that like freaking instantly. So
amazing.
as to the blocking thing with the read-only, we're going to have to figure that out, where I think I'll sit down with Matt after this. And we'll look into that. But the main part.
Well, that's good. We found we got an issue out of the stream at least that we can.
Yeah. So there you go. What's life if you don't learn anything, right?
Exactly.
But it's so that is met because we have been able to download the snapshot and we have applied it, and all of a sudden, like within seconds, we got so much data out of this thing. I think anybody watching this, if you look how many lines of code we ended up using. It's like it's freaking nothing, and we're already there. Now we have a fully functional network graph that we can probably that we could
find the paths.
Yeah, we could find paths with. I don't know if we have the time. It's kind of we've been on here for a really long time.
Yeah, we've got like 5 minutes left anyway, so we're gonna close out in a minute anyway. But yeah, as you can see, it's literally like bar just messing around with building and libraries and that kind of stuff. It's literally like 5 minutes of work, if that, right? So it's easy to implement, which is really good. And yeah, I mean, I don't know if you wanted to cover anything else. We've only got 5 minutes. There's only a few people left in the chat. If there is anyone in the chat that has any questions, feel free to throw them at us now, or forever hold your peace. We've only got 5 minutes left. Is there a? Okay, we've just got a. No, it's all good. It's a mixed bag when it comes to this stuff. But okay, cool. Is that pretty much it then? Like, it's really, as you said, like it's super quick to do and implement and very fast.
Yeah. And if you're using something complicated like React Native or Flutter, then maybe you're not going to be able to run this network request right there easily. So you might need to store the result to a file. But if you do, and you know the path of the file, just looking at the autocorrection or auto-completion suggestions that IntelliJ has. So if you could maybe type an empty line and then rapid gossip sync dot. You see that there it has sync network graph with file path. Honestly, you may want to rename that to from file path because it sounds better. But it allows you to just specify the path to a file where you already have the downloaded snapshot data. And it's going to make things much easier for you if you cannot just trivially pass around 5 megabyte objects.
Okay. That makes a lot of sense. On average, how big is like the, well, I guess that changes a lot, right? But yeah, how big is the network graph like currently? How many megs are we looking at? Like 5, 6? What are we kind of looking at?
Yeah, so it's growing fairly slowly. I think a couple of weeks ago it was 4.7. Now it's it looks like 4.8. But this is the rapid gossip sync serialization.
Yeah.
It's also worth noting that if you exclusively use rapid gossip sync to keep your mobile app up to date, then you're not always going to need the full graph. You are going to be able to just use those incremental updates, and the incremental updates of like, maybe a day or a couple of days, or maybe even a week or two, those are much smaller. And if you want to look at some example breakdowns, I measured it once. It's in it's in the GitHub README, where it says that a day-old sync can be as little as 191 kilobytes, and that is before compression. So after compression, it's going to be like around 90 kilobytes. It's truly, well, not really nothing, but fairly close to it.
Okay. Fantastic. Well, it's great work you've done here. It's going to hopefully be used by a lot of mobile developers and stuff like that. So yeah, we can kind of end the stream there. We're bang on time. It doesn't look like we have many questions, but people can obviously always go back and watch the YouTube video that we're going to upload. We're going to provide a lot of the resources that we've gone through in this stream in the show notes as well. So feel free to share the video once it's up on YouTube as well. Did you want to leave the people like with any last messages around RGS or Bitcoin in general or anything like that?
Yeah, well, I think I'm going to regret this, but if you are working on implementing RGS or really anything that we've been talking about in this video, and you need some help, feel free to join our Discord and either message channel, or you can message me. I think my username in the Discord and the LDK Lightning DevKit Discord is also Arik Aleph, or maybe it's just Arik. But point is, you'll find me, and I'm happy to help out. So really, anything we can do in order to make mobile apps more privacy preserving for Lightning, it's probably our top priority.
Yeah, it's a big win. It's a big win. All right, cool. So yeah, thanks for people tuning in. Thanks for the people who are going to watch this on the playback as well. Like Eric said, feel free to jump into the LDK Discord community, hang out with us, ask questions, contribute, use LDK, and let us know if there are any other topics you'd like us to cover over a live stream, and we'd be happy to do that. So Eric, thank you so much for joining me. It's been a pleasure spending time chatting with you and coding with you, and I'll catch up with you soon. Yeah,
pleasure was all mine. Thanks, Connor.
No problem.
Bye.